This conference will now be recorded.
Today also I am opening Anaconda Navigator. Yesterday we discussed about print command, of course working with various environments. The first chapter and second chapter I will show you Anaconda Jupyter Notebook. Next we will work with IDEs. So we already understood how to work with IDLE and Python console, working at command prompt, how to write the programs in the text editors and how to execute from the command prompt. These all things we understood. And as well, we understood about first chapter print command. What are the various ways of working with print command, SCP attribute, end attribute, and also variables and values, how to make variables in Python, and data types. So type function, ID function, and also we understood type conversion functions and number systems supported by Python. These all things we understood. Conversion functions we understood. Today we supposed to begin with the Python memory model. So little bit about this memory model we understood yesterday, but today let us understand this memory model deep. So as I told you, Python is a dynamically typed programming language. The other languages are static data type supporting programming languages. The languages C, C++, Java, C#. These are static data type supporting programming languages. In these languages, we have to declare the variable. So first we have to declare variable, then only we can use it. So explicit declaration of the variable is mandatory before going to use it. This is what basic nature of the static data type supporting languages. I'll do comparatively. First, let us understand the memory model of other languages. A lot of you people know about them. So here we have to declare the variable. Generally, we do declare variables like this: int a, semicolon. This is variable declaration. Sometimes we do initialize the variable int b is equal to 65, like this. Declaration itself. Okay, we'll be initializing variable. Of course, we may do like this: int c, int d. Like this, we supposed to declare variable. Of course, C language, C++, Java, C#. This is the syntax. So how the memory allocation and how the variables are created in these languages, if you understand, A is a variable, so variable A is created It is integer data type. According to the data type, the 4 bytes memory or 2 bytes memory, it occupies the amount of memory according to data type. The memory block has its own memory address. This is the memory ID. Please observe, in these languages, in the static data type supporting programming languages, variable is the owner of the memory. Variable is fixed, memory is fixed, memory address is fixed. The variable is owner of the memory. At present, there is no value in the variable A. Similarly, variable B, this is also integer data type. It occupies the memory according to the data type, and this memory has its own memory ID. The value stored in this variable is 55. Actually, variable is fixed, variable is owner of the memory. We do store value in this variable. Similarly, variable C, the C is the variable created. It occupies memory according to the data type. The memory block has its own memory address. Similarly, another variable D is created. It occupies memory according to the data type. It has its own memory address. This is how variables are created. Suppose further I am writing like this. A is equal to 78. B is equal to 23. C is equal to 55. D is equal to 55. Like this I gave. I am assigning value to A. I am modifying value of B. I am assigning value to C. I am assigning value to D. What happens in this case? The value stored in A is 78. Variable not changed, memory is not changed. Just value is assigned to variable. The value is stored in the variable. Next, B is equal to 23. B already contains a value 55 that is erased. Now the new value 23 is stored in this. So variable B is fixed, memory is fixed, but value is got modified because owner of the memory is variable. Next, C is 55. The value 55 is saved here. D is 55. The value 55 is saved here. Suppose I gave D is equal to A. I am assigning A into D. So A is 78. The D, the value is modified to 78. Okay. This is how the memory allocation and storing the values, modifying the values done in other languages. For example, again, A is equal to 43, B is equal to something like 98, C is equal to 43, D is equal to 25. Suppose I give like this. What happens? The value of A is modified. The value of A is modified. Now the value of A is not 78. Now the new value is 43. Value of B is not 23. Already 23. Now the new value 98 is given. then value of C is already 55, that is removed, and now the value of C is 43. The value of D is now 25. This is how the memory is organized in the other languages. These languages are static data type supporting programming languages. I hope all of you know about it already. I think anybody is new, you understood it. But this is not the Python memory model. This is how the memory is organized in other languages, static data type supporting programming languages. If you try the same in Python, what is the memory model? If you understand Python memory model, Python is a dynamically typed programming language. You must not declare variable explicitly. Explicit variable declaration is not required. You should not do it. Directly use the variable. Directly use the variable. Of course, I am doing the same. A is equal to 78. B is equal to 55. C is equal to something like I am giving 43. D is equal to 55. This is what I give. Suppose if I give like this, what happens? What I told you yesterday in Python prospective, the value is the object. Value priority is given to value. The value itself is the object. What's about variable? What's about variable? Variable is just identifier. Variable is reference variable. Variable is reference variable, right? So 78 is the object here. Is the object 78 already available in memory? No, the object 78 is not already available in memory. So it creates object 78. How much memory is required for that? That much memory is occupied. This memory block has its own memory ID. Okay. This is 78 is the object. Object occupies memory and it has its own memory ID. Then what is A? A is just a reference variable. A is pointing this object, right? A is reference variable that is referencing this object. A is pointing this object. Next, B is equal to 55. Here 55 is the object. Is the object 55 already available in memory? No, the 55 object 55 is not already available in memory. So it creates new object 55, occupies necessary memory. The memory has its own memory ID, right? Okay. So B is the variable, B is the reference variable which is referencing this object. Please observe carefully. B is the reference variable which is referencing this object. Next, C is 43. Is the object 43 already available in memory? No, the object 43 is not already available in memory. So create a new object 43. It occupies the necessary memory. Here there is no limit, integer 4 bytes only. float 8 bytes, such limit is not there. In Python, it is unlimited. So how much memory is required for the value, that much memory occupies, right? So this is the memory ID of C. C is variable. C is variable. This is identifier. It is a reference variable. So it is pointing 43. Next, D is equal to 55. The object 55 is already available. The object 55 is already available. D is the variable that is pointing the same object 55. Okay, it is assigning same object 55. Okay, fine. Next, let us observe further. I am doing like this. Suppose A is equal to 43. I am giving B is equal to 23. I am giving. Okay. C is equal to 78. I am giving. D is equal to 25. I am giving. What happens in this case? 43 object already available in memory, variable A already available in memory. So A shifted to 43. Now A is referencing 43. Okay. So what's about 78 now? 78 is an object. Still it is available in memory, but it is the object which does not have any reference variables. The object which does not have any reference variables. Of course, if the object is like that for the longer time, on a standard interval, the garbage collector will collect the unused memory objects. The object which does not have any reference variables, those are known as unused memory object. Such unused memory objects will be residing in the memory. Whenever the garbage collector comes and scan the memory, it will clear all the unused memory objects. Until then, it is available in the memory. Okay. Now B is equal to 23. Is the object 23 already available in memory? No. So it creates the new object 23. It occupies the necessary memory. It has its own memory ID. This occupies its own memory ID. Right? So what is this? This is B. So B variable already there. Now the variable B is referencing 23. Originally, it is not modifying the value. The variables are shifting to the another objects. So object does not modify. If 78 is 78, 55 is 55, 23 is 23, 43 is 43. So this doesn't modify. The object doesn't modify. Only reference variables are shifting between. See here, C is equal to 78. 78 is already available. Now the C shifted to 78. Now D is equal to 25. So object 25 is not already available. So it creates the new object 25. It occupies memory. It occupies memory. It has its own memory ID. So now D is the reference variable referencing 25. Now 55 become as unused memory object. Such unused memory objects later on collected by the garbage collector. When the garbage collector comes, the garbage collector scans the memory on a standard interval. This is how the immutability memory model in Python. What is immutable object? Object does not allow changing its value. Just once you observe, is the object getting changed in this memory model? No. 78 is 78. It is fixed. That cannot be changed. 55 is 55. That cannot be changed. 43 is 43. That cannot be changed. So this is immutability based memory model. Only the variables, reference variables, are shifting between the objects. It is checking whenever you are assigning a value to the variable, it is creating object. Before going to create object, it is checking whether the object is already available or not. If the object is already available in the memory, it references the same existing object. If the object is not already available in memory, then it creates new object. This is basic understanding, overall understanding about the Python memory model. Practically, let us observe this practically. Of course, let me show you in IDLE. The same thing I will show you in IDLE. See, what is A? A is equal to 78. I'm printing what is A, what type of object it is, type of A, and also what is the ID of A. This is what I am printing. Okay, this is about A. Next B, B is equal to 55. Similarly, I am printing B. What is B? What is the type of B? What is the ID of B? If you observe, this is integer, this is integer. This 78, this is the memory address of the object 78. This is the memory address of the object 55. B is referencing that. Then C is equal to 43. So let me print information about C. What is C? What type of object it is? What is ID? Okay, then D is equal to 55 again. D is equal to 55. Let me print about the information about D. Okay, now you observe 55 is the object. This is the memory ID. Here also 55 is the object. This is the memory ID. Both are same. So B is pointing the same object. D is also pointing the same object. Okay. Now I do modify A is equal to 43. Now print about A. So A value is 43. This is the memory ID. Previously C is pointing 43. Is it the same memory ID or not? Now value of A is modified, but A is now pointing 43. Next B is equal to 23. Now print the information about B. Yes, now value of B is modified. That means new object 23 is created. B is referencing the 23 now. So previously B is 55. This is the memory ID of 55. Now the B is pointing 23. This is the memory ID of 23. C is equal to 78. Now print the information about C. Type of C, ID of C. So previously, which one is 78? A is 78. Of course, 78 is A is shifted to 43. Now this is 78 is unused memory object, but still that object is available in memory, so C is pointing the same. In case by the time garbage collector has been collected that object, now 78 is no more present in the memory, it creates the new object as it is required now. Okay, this is how. Okay, D is equal to 25. Now print information about D. So I hope all of you understand basically the memory model of the Python. This is immutability based memory model. If any questions as of now, please let me know. All of you clear about it? Any questions? No questions, no doubts. Okay, good.
So, Srini, one thing. Yeah, if the already object got memory filled all, so how it goes? It will create one more memory allocation with the same object.
No, if the object is already available, it references the same object. One
Yeah,
more variable
yeah,
also pointing the same object.
yeah. If the memory is like in the memory got
You are
full,
asking that if the
yeah,
object become unused memory object, garbage collector is already collected that. Now I want to create it. Yes, obviously we have to create once again.
no, the memory if it is filled almost is over. Like whichever the like, is there any limit of using number of identifiers to that particular object? I'm saying.
No limit, unlimited.
Okay, if the memory in
No.
that particular object got completes, means other object will get created with the same object ID.
I'm not getting your question. If the memory of the particular object is fill,
All
what does it mean?
see,
What you are asking
yeah,
that?
see like whatever the memory is there, like some memories are allocated to a particular object, like 78.
No,
So
please leave that mindset, the Java, C++, C Sharp mindset. Integer is 4 bytes memory, or any data type has certain memory limit. Please leave it. Here there is no memory limit. For everything, unlimited. As per the requirement, as per the necessity, memory will be keep on added. Okay.
okay, so there is no need of creating the one more with the same objective, right?
Of course, you are working in your own natural way, but Python is internally working this. This is internal reactions. See, here 55, B is 55, C is 55. B and C both are pointing the same object. Suppose X is 55, I is 55. They also pointing the 55. 55 is only one object. Maybe multiple variables are referencing the same object. But as we are working, we feel that I'm assigning value to the 78 to the A, I'm assigning value 55 to the B, I'm assigning value 55 to the D. That we will be working regularly, right?
Yeah, yeah.
Understand?
Yes,
So it
yes,
is
yeah.
not
I got
making any complexity in our regular nature of working. It is only internal memory management mechanism of the Python.
it. Okay, yeah.
Okay.
Understood. Yeah, yeah, understood.
Now this again, this nature, this is the basic nature. Of course, most of the times this only works, but when you are working in interactive mode, some differences you will be able to observe. So here I'm classifying this memory management behaviors three different ways. One is for the Boolean data type, one is for the Boolean data type. If you think about Boolean data type, how many values for the Boolean data type? Whether you have a million variables or trillion variables, it doesn't matter. But values are either true or false. That's it in case of Boolean data type, right? So here object is true, one object is true, another object is false, another object is false. Here T should be capital. F should be capital. This is an object, this is an object. What all variables value is true, they all are pointing true only, this object only. Maybe it is 1 million variables. What all variables contains the value false, they all are referencing false only. Maybe this is 1 million variables, right? So multiple variables pointing the same object. So in case of Boolean data type, what happens? First it will check whether the object is true, already available in the memory. If it is not available, create the new object true, reference it. If it is already available, refers the existing one. Again, if it is already available, refers the existing one. So this is the nature of the Boolean. This is what I explained here also. This is Boolean data type. So it will check whether the object is already available in the memory. First of all, if the object is not available, create the object. If in case the object is already available, refer the existing object. Don't create the new one. That is the nature of the Boolean data type. Okay. Next, float data type and complex data type. This behavior is different. Float data type, complex data type. This behavior is different. Okay. Here, it doesn't check whether the object is already available or not. There is no, in case of float data type, in case of complex data type, it doesn't check whether the object is already available or not. Each and every time, it creates new object blindly without checking whether the object is available or not. Please observe here. Here you see integer data. Okay, integer I will discuss later. See, float data type. A is 75.23, C is 75.23. Okay, both are 75.23. B is 85.48, D is 85.48, X is 25.12, M is 25.12, Y is something 36.34. Just you execute and observe. What is the memory ID? Here A, this is 75.23. 75.23, different memory ID, right? So first time 75.23, it creates new object. Next 85.49, it creates new object. Next 75.23, it creates one more object. Again 85.49, it creates one more object. 25.12, it creates one more object. 36.34, it creates one more object. 25.12, it creates one more object. Each and every time it creates a new object without checking whether the object is already available or not. But in case of I is equal to y, I am assigning to I, so the memory ID of y, memory ID of I is the same. Why? Because, for example, if I give like this, suppose I wrote my statement like this, x is equal to a. So what I am assigning to x? Whatever is there in the a, that I am assigning to x. What is there in the a? Memory ID. What the a is referencing? Memory ID, right? So the a is assigned to x. A is assigned to x, right? The memory ID referenced by a, that I am assigning to x. So x is also pointing the same. So memory ID of x and memory ID of a both are same when I give x is equal to a, right? All of you clear? Because a is assigned to x. That's the reason. Similarly, in case of float also it is the same. Y, what is y? Y is this This is the memory ID. That y I am assigning to I, simply I is pointing the same. Similarly, D, what is D? This is D, right? So D I am assigning to J, so J is also pointing the same. This is what happens in case of float data type. Similarly, in case of complex data type also, in case of float data type, in case of complex data type also, each and every time it creates a new object. Simply see, this is the complex. You observe, every time it creates new object created, 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 new object created. But here m is equal to D. What is D? This is D. This is what assigned to m. So m address and D address both are same because both are pointing the same object. In case of Boolean, you see all trues are having same ID, all false are having same ID. But in case of Boolean, it is in case of float, each and every time it creates new object. In case of complex, each and every time it creates new object. All of you understand about Boolean, float, and complex nature? Any doubts? Sai Shravanti is asking that how we do know if the garbage collector is collected it already or not. Why should you know? My question is, why should you know? First thing, because Python is dynamically typed programming language. We don't have any chance of declaring the variable. Nothing is in our control. We don't have anything to control over there. Everything is automatically happens implicitly. What actually Python does internally, that is what the memory model we are understanding. We don't have chance to control a variable, right? We don't have chance to specify allocate memory so and so. We don't have control. This is the major difference between other languages and Python. In other languages, we are declaring variable. Without declaration, you can't use. Everything is in programmer's control. But Python, everything happens internally. Okay. So don't worry, don't take very serious about it. But inside the Python, implicitly, internally, the things are happening. How those things are happening, we are trying to understand. One point. And another point. This behavior is differs in the interactive mode. Now I am showing you interactive mode. These IDs and everything I am showing you in interactive mode. But in the script mode, same thing is different. Okay. In the script mode. So in case of script mode, you are writing a program, save the program and execute the program. When the program execution going to complete, when the program execution going out of scope, then before completion, the garbage collector clear the memory and program execution will be completed. That's what happens. In case of interactive mode, this is a long session. Right? See, I open IDLE. This is kind of a program. I open IDLE. Session started. I might be executed 2 commands. I might be executed 200 commands. I might be executed 2000 commands one by one. I might be working with for 1 minute. I might be working for 1 hour. I don't know. This session is open. So on a standard interval, we don't know what is that interval. On a standard interval, garbage collector will be keep on collecting the memory. This happens in the interactive mode. In case of script mode, at end of the program execution, garbage collector will clear all the resources of the memory resources of the program. Then only program gets closed. Is it clear, Shravanti? So here I am explaining very deep about this memory model not to confuse. Okay, nothing is in your control. Just you are trying to understanding what is happening internally, so that further complex program development, when you are understanding a program, when you are analyzing logic of a program, you have to build that logic in Python mindset, according to the Python memory model. You have to understand your logic and analyze your logic according to this memory model, so that you can build the perfect logic. Most of the people do the mistake because they are already Java expertised people or C# expertised people. They know very well about program logics and building the program logics. So they are thinking in the Java mindset or C# mindset, but writing the logic program in Python, but program doesn't work in that mindset. Python works in Python mindset. This memory allocation scheme is different. So many situations the logics will go wrong. For that maturity levels only, what is Python mindset, how you have to think about Python program execution while understanding the variables and allocating the values to the variables, and these all things, for the better maturity levels I am explaining this very detailed. Okay. Then integer data type and string data type is little differ. So these both behaviors will be there in case of integer data type and string data type. Integer data type and string data type. Now the differences, what I am telling you, that is only in interactive mode, not in script mode. I will show you the same in script mode also. See, once you think yourself, you tell me, most of the times in our programming, in our logic execution, in our algorithms, whatever whatever programs we are developing, most of the times we are working with integers. Maximum we do work with integers, allocating the memory, deallocating the memory for integers. Let you assume that working with integers is just like a float or complex. It is very tedious. So the system is very busy, process is very busy in allocating the memory, deallocating the memory for the integers, right? System is very busy in allocating memory, deallocating memory in integers. So here it follows integer pooling. Integer data type and string data type follows integer pooling. The integer pooling range is, the range of the values, integer pooling is -5 to 256. This is the integer pooling range. This is integer pooling range, -5 to 256. This is integer pooling range. The values outside this is outside integer pooling. Okay, this is integer pooling. Once you observe, read what is integer pooling. Please read this paragraph. Integer pooling. Typically, Python programs spends much time in allocating and deallocating integers. These operations should be very faster. But if it is a float kind of memory allocation scheme, it's going to be very tedious. So the Python uses a dedicated allocation scheme with much lower head in terms of space and time. Python generally pools the integers between -5 to +256 in a pre-allocated objects list. This integer pooling is also applicable for the strings because it is working based on the ASCII character set, that is 0 to 256. 0 to 255, right? So that's why. So it is applicable to integer, it is applicable to string. This is not applicable. Integer pooling concept is not applicable for float and complex. So according to this integer pooling, in between the range -5 to 256, multiple values have the same IDs. IDs are same even though you have multiple times the same value. Okay, that is integer pooling. Now you observe integer data type related. You try to understand. This is Boolean, you already understood. Float and complex, you already understood. Now you observe this. A is 55, C is 55, B is 178, D is 178, E is 255, F is 255. This is inside integer pooling range. So all 55s has the same ID, all 178s has the same ID, all 256s has the same ID, right? Because the all values are inside integer pooling. Now you observe this is outside integer pooling, -8, -8, -8, that is below -5, outside integer pooling range. -250 plus 259 plus 259 plus 259. This is outside integer pooling range. Each and every time it has a different ID. -8, every -8 has its own ID, so it creates its own separate object. So 259 has its own IDs. It creates each and every time it creates a separate object. This is outside integer pooling range. See here, string, single word string. IDs will be the same. Apple and apple, ID is the same. Banana, banana, ID is the same. Orange, orange, ID is the same. Because it is a single word string. This is multi-word string. IDs are different. Apple is red color. Apple is red color. ID is different. Each and every time it creates new object. Banana is yellow color. Banana is yellow color. ID is different. Right? This is how it works for the strings. So far, what I told you, this behavior is only while you are working with the interactive mode. Same thing, let us try in script mode. Of course, I'm opening IDLE. In the IDLE, I'm opening a new script. I'm writing this statement, Boolean. First, I'm taking Boolean. Writing the script here. Save it. Yes, I'm overwriting the existing. Now run this. Observe here. All truths have the same ID, all falses have the same ID. This is Boolean. In case of Boolean, we don't have any confusion. Same thing you try with float in script mode. I'm writing this script. Save it and run it. Here it is a float. Even though float values have the same ID, right? Observe carefully, because it is script mode. Because it is a script mode, right? So in this case, natural, if the object is already present, refer the existing object. If the object is not already present, create the new object. This is what happening in case of float also. This is in script mode, no differences, no much differences. In case of complex also, observe the complex. So this is the area where you need to do some experiments to understand much better about this memory model. See, complex data type, save it and run it. In case of complex data type also the same. So 5 plus 8j, 5 plus 8j have the same memory ID. 4 plus 5j, 4 plus 5j has the same memory ID, right? So in case of Boolean, in case of float, in case of complex, in case of integer, string, it is the same. Just let you observe this inside integer pooling range, it's okay. Let us observe when it is outside integer pooling range in the script mode, what is happening. save it and run it. Save it and run it. Now you observe. So all -8s are having same ID or not? All 259s are having same ID or not? So Boolean, float, complex, integer, that is outside integer pooling, everything is functioning the same. In case of string, single word string, it's okay. Let us observe with the multi-word string. In case of script mode, it is uniformly working. Commonly, it is the same memory model, but this differentiates in the interactive mode. Now you run it. Here also, apple is red color, apple is red color. ID is the same or not? The common, same memory model, right? This is a Python memory model. So final conclusion is, this you try to understand memory model, you get the clarity, you understand about the memory model, but please do not get confused. Please do not think about taking that into your control. Programmer does not have any control about variables. This is not static data type supporting language. We don't have any control. Python behaves internally. Everything Python does automatically internally. It is only the best way, the better extent, how much we are able to understand the internal behavior of the Python in case of interactive mode, in case of script mode, in case of various data types, how it understands. We just understood, we just realized. Keeping this knowledge in the mind while building your logics, your big programs, but you cannot control it. Accordingly, you have to build your logics. This is a Python memory model. All of you clear about this memory model? Do you have any confusion, any questions? Please let me know. We'll conclude this memory model. Anybody is having any questions? Serious questions, silly questions, funny questions, problematic questions, all? Is everyone well understood about Python memory model? I hope so. So Python behaves its own way, but you try to understand it. That's all. Whenever you execute the program, for the understanding about internals, you have function, ID function, you have function type function. So you can know what is the data type, you can know what is the ID, so that you can understand that whether the multiple objects are pointing the same, of multiple references, multiple variables are pointing the same object, or multiple variables are pointing the different objects, that you will be able to understand, right? This is Python memory model. Next, let us try to understand operators in Python. Operators in Python. We have different operators in Python. This is very easy for you people. So we have different operators supported by Python. One is arithmetical operators. Second one is relational operators. Relational operators, also known as conditional operators or comparison operators. And logical operators. Third one is logical operators. Arithmetical operators. Relational operators. Relational operators, also known as comparison operators or conditional operators. Logical operators, and operator, or operator, not operator. These are logical operators. Bitwise operators. Bitwise operators process done at binary level, bit level. Bitwise operators. Bitwise AND operator, bitwise OR operator, bitwise XOR operator, bitwise left shift, bitwise right shift. Okay, and assignment operators, membership operators, In operator, not in operator, these are membership operators and identity operators. Is operator, is not operator, these are the identity operators. So these are the operators. First, let us begin with arithmetical operators. You people know very well about these arithmetical operators. Plus is for arithmetical addition, hyphen is for subtraction, star is for multiplication, slash is for division, percentile symbol is for modulus. These operators you know very well. Okay. But here we have two more operators, that is a double slash. This is floor division, sometimes also called as integer division, integral division. This is floor division. And we have double star symbol. This is exponential power to the power of. These are the arithmetical operators. Just observe this. I is 56, J is 75, I plus J gives you total 56 plus 75. I is 96, J is 75, I minus J gives you I minus J, 96 minus 75, 21. So I is 50, J is 4, multiply, I multiply with J, 50 multiply with 4, that is 200. But in case of division, you have to understand. So division, all of you know this. (37) divided by 5. This is what we are doing, right? 37 divided by 5. So this division operation, when we do this division operation, 7, that is 35. Okay. So remainder is 2. We can stop division at this situation, no problem. This is what we do division. We can also extend this, right? This can be extended point, here 20, here 4 is 20. This is what simple division. This is what a simple division, right? This is what simple division. Result of the simple division is quotient value. This is simple division, single slash output. Integer division, that is a floor division. That is floor division. Output is this one. This is the floor division output. So decimal extensions will not be there. Only integer output. Only integer output. Then modulus, remainder of the division is this one. Modulus, remainder of the division is this one, right? Understand? So observe here, 37 divided by 5, simple division, the output is 7.4. Floor division is 7 only, modulus is 2. Okay. Then double star symbol is exponential power I to the power of j, that is 7 to the power of 5. This is the output. These are the arithmetical operators. Next, relational operators. Relational operators are comparison operators, comparing two values, equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to, right? Now you observe this example. Of course, this performs the comparison. It checks the condition, gives you true or false. If the condition is satisfied, it gives you true. If the condition is not satisfied, it gives you false. Just observe here, A, B, C, D, E. These are the variables. I am printing all the variable values. Then A is equal to C. A is 25, C is 25. Both are equal. That's why it returns true. A is equal to B. A is 25, B is 76. No, both are not equal, so false. A is not equal to C gives you false. A is not equal to B gives you true. Then B is greater than D. Yes, B is bigger than D, gives you true. C is greater than D, false. A is less than B. Yes, true. B is less than D, false. Similarly, greater than or equal, either bigger than or equal, less than or equal, either smaller than or equal. It gives you true or false. If the condition is satisfied, it gives you true. If the condition is not satisfied, it gives you false. These are used to check the condition, compare two values or two variables. That's why these are relational operators, conditional operators, or comparison operators. Okay. Logical operators are used to combine multiple Boolean expressions or conditional expressions. So the syntax of the using logical operators is left operand is a condition 1, operator, right operand is condition 2. So either it is condition 1 or true or false. The condition basically gives you true or false only, right? This is true or false. Similarly, condition 2 is also either true or false. So here if you are using operator and operator, so condition 1 gives you true, condition 2 also gives you true. Ultimately it gives you true. Both are true, so that ultimately it gives you true, right? Condition 1 is true, but condition 2 is false. Ultimately it gives you false. Condition 1 is false, condition 2 is true, then also it gives you false. When both are false, then also it gives you false. This is AND operator. So to combine multiple conditions together and use it as a single condition, okay, single checking. So in case it is OR operator, so either first condition or second condition, either one condition is true, it is well and good. So both are true, it is true. Either one is true also, it is true. When both are false, then only it is false. This is OR operator. Negation operator, not operator is negation operator. Not operator is negation operator. Not true gives you false. Not false gives you true, right? This not operator is a negation operator. That examples you can see here. Here directly I am giving Boolean values. A is true, B is false, C is true, D is false. A and C, true and true. A and B, true and false. B and C, false and true. B and D, false and false. Similarly, OR operator, true or true, true or false, false or true, false or false. Just observe the outputs. Okay, here I am writing some condition. Of course, condition also gives you true or false. J is equal to L. L and J both are equal, so condition is true. I is less than K. I is 15, K is 56. Yes, I is less than K. This also gives you true. So true and true. J is equal to L, true. I is greater than K, false. J is not equal to L, false. I is less than K, true. J is not equal to L, I is greater than K, false, false. Okay, similarly AND operator, OR operator, both. So how it works? It gives you Boolean expression. These are the logical operators. Not true gives you false. Not false gives you true. Right? These are the logical operators. Next, let us understand bitwise operators. Bitwise operators are performed at binary level, bit level. You try to understand this in a bit level. See, observe this. A is equal to so and so, B is equal to so and so. My input is binary. Even though my input is binary, by default Python take it in the decimal number system. By default Python takes it in the decimal number system. So A is equal to 805, B is equal to 617. Let me show you this in IDLE also. What is A? A is equal to 805. What is B? B is equal to 617. So A is 805, B is 617. Observe binary mode, bin of A, bin of B. This is the binary level. Okay. Now what is A and B? A bitwise and B, that is 545. A bitwise AND operator B, the value is 545. Why it is 545? You have to observe in binary level. Bin of A and B. Now you observe, you will be able to understand. Please observe A. This is the binary value of A. A is equal to, this is the binary value. 0B represents, it is binary. There's nothing special. It represents, it is binary. B is equal to, of course, let us take it here. Okay. So this is the binary value A, this is the binary value B. If I am doing the operation A bitwise AND operator B, what happens? So 0B, that represents binary. Here first digit is both are ones, so it gives you 1. Second digit is both are different, either 1 0, so it is give 0. Both are zeros 0, both are different 0, both are ones 1, both are zeros 0, both are different 0, both are different 0, both are zeros 0, both are ones, it is 1. Right? 1 triple 0, 1 double 0 double 0 1. Is this the output? 1 triple 0, 1 double 0 double 0 1. So this binary value decimal number is 545. This is how it is processed in the binary level. This is bitwise AND operator. Similarly, you observe bitwise OR operator, same values. A is 805, B is 617. Bitwise OR operator, you see A bitwise OR operator B, that is 877. If you observe this in binary, bin of A bitwise OR operator B, you can observe in the binary level. What happens? Here my operator is A bitwise OR operator. OR operator in the sense both are ones, it is 1. Either one is 1 also, it is 1. When both are 0, then only it is 0. Either one is 1, so it is 1. Both are ones, it is 1. Both are zeros, it is 0. Either one is 1, it is 1. Either one is 1, it is 1. Both are zeros, it is 0. Both are ones, it is 1. 110, 110, 110, 1. This is what? Is it 110, 110, 110, 1? Okay. This is bitwise OR operator. Then bitwise XOR operator. If you observe what is XOR operator, bitwise XOR operator. If both are equal, if both are same, so both are ones, it is 0. If both are different, it is 1. Both are zeros, both are same, it is 0. Both are different, it is 1. Both are equal, 0. Both are equal, 0. Both are different, it is 1. Both are different, it is 1. Both are equal, 0. Both are equal, 0. Absolute left 0, Python ignores. So 1 0 1 0 0 1 1 0 0, is it? XOR 1 0 1 0 0 1 1 0 0. Of course, absolute left one more 0 is there. Python ignores absolute left zeros. This is bitwise XOR. Bitwise left shift, bitwise right shift. Carefully understand this bitwise left shift, bitwise right shift, because this is a binary array, binary value. This is a bit array, binary array. Try to understand like this. These are the values. This is binary array, binary digits, array of binary digits. Okay. The binary array is like this. These are the array of binary digits. This is a bitwise bits, 0 or 1. So this is my value A in binary. Now A left shift 2. A left shift 2. That means move 2 digits left. Move 2 digits left. See, this is the binary value. This is your binary value. Move 2 digits left. So 2 binary digits move left. Then according to the binary process, your value is going to be this. So right side 2 empty, those are filled with 0. So this is your binary value. Similarly, A left shift 3, move 3 digits left. Move 3 digits left, right? This is your binary. 1 2 3 digits move left. Okay, so then this is what your final binary. So here right side you will have 3 zeros. Okay, this is the left shift 2, left shift 3. You observe, I'm showing you in numerical digit level, decimal number level, and as well binary level. I hope you understood. Similarly, right shift operator, right shift 2, right shift 3, you can do it. Okay, let us observe that also. This is left shift. In case of right shift 2, in case of right shift 2, this is your binary. Move 2 digits right. Whatever is moved right side, that is out of scope. These are not considered, they gone out. So here absolute left, you have 2 blanks, they fill with 0. Anyhow, Python ignores absolute left zeros. So this much is the value. Similarly, A right shift 3, 3 digits move right. 3 digits move right. Observe here. This is your binary 1, 2, 3 digits gone out. So scope is this much. Okay, these are gone out. So here left side 3 blanks, so fill with 0. Absolute left 3 zeros. Python ignores absolute left zeros. Then this is the output. That is right shift 2 and right shift 3. These are the bitwise operators. I hope all of you understand this bitwise operators, bitwise AND operator, bitwise OR operator, bitwise XOR operator, bitwise left shift, bitwise right shift. These operators all of you understand. Next one is assignment operators. Next one is assignment operators. So you know, here simply if we give A is equal to 25, equal to is the assignment operator. We are assigning value 25 to variable A. This is what we know. This is a assignment operator, general. But in Python, we have assignment operators like plus equal to, hyphen equal to, subtraction equal to, multiplication equal to, division equal to, floor division equal to, modulus equal to, exponential equal to. Like this assignment operators are there. Bitwise assignment operators also there. Bitwise AND equal to, bitwise OR equal to, bitwise XOR equal to, bitwise left shift equal to, bitwise right shift equal to. These are the assignment operators. Plus equal to, what does it mean? If you write A plus equal to B, it means A is equal to A plus B. Similarly, if you write A minus equal to B, that means A is equal to A minus B. Assign back to the same variable. A multiply equal to B, that means A is equal to A multiply B. A slash equal to B, that means A is equal to A divided by B. A double slash equal to B, that means A is equal to A integer division, floor division B. A percentile equal to B, that means A is equal to A modulus B. A exponent equal to B, that is A is equal to A to the power of B. This is what the meaning. Of course, you can write in this shortcut manner. Actually, it processes like this. Either you can use this syntax or this syntax, anything is okay. Now, A bitwise AND operator equal to B, that means A is equal to A bitwise AND B. A bitwise OR equal to B, that means A is equal to A bitwise OR B. A XOR equal to B, that means A is equal to A XOR B. A left shift equal to 2, that means A is equal to A left shift 2. A right shift is equal to 2, that means A is equal to A right shift 2. These are the assignment operators. These are the assignment operators. Of course, enough examples are given here. You can go through one by one example and you can practice them. Okay. So you can observe yourself. These are the assignment operators. You have membership operators. Membership operators, in operator, not in operator, is used to check whether it is available in. Is it available in? So are you member of so and so? So are you member of Lions Club? Yes or no? If you are a part of that, you will say yes. If your name is there in the members list, you will say yes. Otherwise, no. Similarly, mostly this membership operators works with the collection objects. String is one of the collection object. String is collection of characters. Let us observe here. Here S1, S2, S3, S4, S5, S6, these are the strings. S1, hello, welcome to Python programming. S2, TO2, S3, Python, S4, WEL, S5, PRO, S6, Java. These are the string objects. S2 in S1, S2, TO2. Is it available in S1? Yes, it is available in S1. So in operator gives you true, not in operator gives you false. S3 in S1. What is S3? S3 is Python. Is it in S1? Yes, it is available in S1. So S3 in S1 gives you true, not in gives you false. S4 WEL. S4 in S1. Is it available in S1? Here WL, but here W is capital, here W is small, so WL is not available. So in operator gives you false, not in operator gives you true. S5, S5 PRO. This PRO is available in S1. Yes, it is there. So in operator gives you true, not in operator gives you false. S6 Java, it is not available in the string. So in operator gives you false, not in operator gives you true. Similarly, you observe here, this is the list. LST1 is the list object. Of course, later we will discuss deeply about list object. Just quickly understand this. This is a list object, collection of values. A is 21, B is 67. A in LST1, 21, is it available in the list? No, 21 is not there in the list. So A in LST1 gives you false. B, 67. Yes, 67 is available in the list. Of course, whether it is single occurrence or multiple occurrence, it doesn't matter whether it is available or not. Yes, it is available. So B in LST1 gives you true. A not in LST1 gives you true. B not in LST1 gives you false. This is in operator, not in operator. These are membership operators. Next, you see identity operators. Is operator, is not operator. These are the identity operators. See, observe here. I'm opening IDLE again. A is equal to 125. B is equal to 125. C is equal to 125. So what is A? 125. What is B? 125. What is C? 125. What is ID of A? What is ID of B? What is ID of C? They are pointing the same object. 125 is the object. Variable A, variable B, variable C. They are pointing, they are referencing the same object. Suppose if you give A is equal to B, what does it mean? It is comparing 125 is equal to 125, the value comparison. Suppose I am giving A is B, that means ID of A is equal to ID of B. Is both variables pointing the same object? So it is true. Same thing you try with float. X is equal to 23.5. Y is equal to 23.5, Z is equal to 23.5. If you observe, what is X, what is Y, what is Z? So X is equal to Y, it gives you true because 23.5 is equal to 23.5. Okay, what is ID of X? What is ID of Y? What is ID of Z? If you observe, they are different. So X is Y gives you false. Why? Because X is pointing a different object, Y is pointing a different object, both are not pointing the same. That is operator, is not operator. You observe here 123, 123. Equal to operator gives you equal, but is operator is nothing but ID of A is equal to ID of B. Is not operator is nothing but ID of A is not equal to ID of B. Is operator gives you true, is not operator gives you false, because both are pointing the same object. In case of outside integer pooling, 258, 258, both the points are different objects. So here it is different object, Y is different object. That's why is operator gives you false, is not operator gives you true. But simple equal to is comparison of the values that gives you true. This is identity operators, comparing the memory IDs to find out whether both the objects are referencing this, both the variables are referencing same object or not. To find out that, we use identity operators. This is first chapter. Chapter 1 is completed. I hope today all of you understood, all of you comfortable about this memory model and operators. If any questions, please let me know. If any questions, please let me know about this first chapter. All of you comfortable? Once you practice, you will become much more comfortable about this. Today, take now it is 5:40. Take 10 minutes break. Okay. Today we'll continue second chapter. Second chapter strings also will continue. I will introduce what is string memory model. Those things I will introduce today. Okay. Please take 10 minutes break. I'll be back within 10 minutes and we'll continue strings chapter. Okay.
Okay.
This conference will now be recorded.
Already in the first chapter, we understood about the string data type. String is a data type. It is, of course, in Python, everything is an object. It is an object type. String is also an object. How do we create a string? String enclosed within a single quotes or string enclosed within double quotes. Either you can enclose within single quotes or you can enclose within double quotes. Either way it is okay. Now you observe, if I enclose the string within single quotes, if I enclose the string within double quotes, both are same. Even ID is also the same. So one point you have to identify, either you can enclose within single quotes or double quotes, both are string. There is nothing but string only. Either way you can do it. This is how you can create a string, a single line string. Single line string enclosed within single quotes or enclosed within double quotes. Then multi-line string, we can make multi-line string, multiple lines of the text enclosed within triple quotes. Start with the 3 single quotes, end with the 3 single quotes. This is a multi-line string. Okay. Either enclose within 3 double quotes, end with 3 double quotes. Triple single quotes or else triple double quotes. Starting with the triple single quotes, ending with the triple double quotes, that doesn't work. Either enclose within triple single quotes or enclose within triple double quotes. This is multi-line string, making multi-line string object. Whether it is a single character, whether it is a single line string, whether it is a multi-line string. In Python, we have only one data type, that is str, class str. These all are string objects. Whether it is single line or multi-line, it doesn't matter. These all are string objects only. If I give like this, what happens? Can you guess and tell me what will be the output of this? What happens in this case? If I give like this, here single quotes is begin, then single quotes end here. This is actually string representation, but remaining is extra. This is syntactically incorrect. This gives you syntactical error, syntax error. What can I do if I want a single quotes inside the string or double quotes inside the string? Single quotes and the double quotes both inside the string. If I want a string like that, what can we do? Do one thing. Here, total string you are representing using double quotes. You are enclosing within double quotes. So inside the string you can use single quotes. Single quotes is considered as a normal character. This way you can do. Suppose I want a double quotes inside the string. The total string is represented using single quotes, so that inside the string you can use double quotes. In this case, double quotes is considered as normal character. In case I want a single quotes and double quotes both inside the string, the total string representation is multi-line string representation, triple quotes, so that inside the string you can use single quotes or double quotes. These are considered as normal characters. This is how you can create a string objects in Python. It's very simple to understand. So please know about this string. String is a collection of characters. String is a collection object. String is collection of characters. So string is collection object. String supports indexing. It supports positive index and negative index. By default, positive index begins from 0, negative index begins from -1. String is collection of characters. So here you need to understand string memory model. See here, this is my string S1. Hello, welcome to is my string. Please try to understand this. S1 is the string object. S1 is the string. This is the string object. Please observe. Hello, welcome to is the string. This is the string object. S1 is the reference variable, references the string object. That is the way you have to understand. So it creates an object. It creates an object that is a collection object, string object. This is the object. This object occupies memory. This is the memory ID. This is the memory address. This is the memory ID, memory address. What is S1? S1 is a reference variable. S1 is a variable, it is identifier. S1 is a reference variable which is referencing this object. Okay. What is this object? This is not an ordinary object. This is not a single value container. This is collection object. It supports indexing. So 0th indexed item, 1 indexed item, 2 indexed item, 3 indexed item, and so on. It is collection of elements. The elements are characters. And one more point you have to remember, string is immutable. String is immutable. These are collection of elements. Okay. So it supports indexing. It supports indexing. Positive index starts from 0. The positive index starts from 0. So this is 0th indexed element. This is 1 indexed element, 2 indexed element, 3 indexed, 4 indexed, 5 indexed, 6 indexed, 7 indexed, 8 indexed, 9 indexed element. This is 10 indexed, 11 indexed, 12 indexed, 13 index, 14 index. How many items are there here? 14 index and 15 index. Yeah. This is positive index. The string supports negative index. The reverse index begins with the -1. The reverse index begins with the -1. Okay, we'll see reverse index later. This is a string collection of characters. Now, what is first letter? First letter is H. Even though it is single character, that is string object only. So the object H already available in memory? No, object H is not already available in memory. So it creates a new object H. It creates new object H. 0th indexed element references the object H. It has its own memory ID that is referred by 0th indexed element. Next, E. Object E. Is it already available in memory? No, it is not already available in memory. So it creates a new object E. 1 indexed element references this E. Next, L. Is it already available in memory? Is the object already available in memory? Not available. So create the object L. 2 indexed element references the L. Next, once again L. L is already available in memory. So 3 indexed element references the L. Okay. Next, O. Is the object O, is it already available in memory? No. So create a new object O. Create a new object O. 4 indexed element references the O. Next, blank space. Blank space is also a character. It's also string object. Is the blank space object already available in memory? Not available. So create a new object. 5 indexed element references the blank space. Okay, next W. Is the object W already available in memory? No, it is not already available. Create the new object W. 6 indexed element references the W. Next, E. The object E is already available in memory. The object E already available in memory. So 7 indexed element references the existing E. Next, L. L is already available in memory. 8 indexed element references the existing L. Next, C. C is not already available. So create the new object C. 9 indexed item references the existing C. Next, O. O is already available. 10 indexed element references the existing O. Next, M. M is not already available. So create the new object M. 11 indexed item references the M. Next, E. E is already available. So 12 indexed item references the existing E. Next, space, blank space. 13 indexed item references the existing blank space object. Okay. Next, T. T is not already available. So create the new object T. So 14 indexed element references the T. O. O is already available. So 15 indexed element references the existing O, right? This is how the string memory model, the string supports negative index also. The negative index begins from -1. It is a reverse index. It is reverse index. So that this is going to be -16. This is going to be -15. This is going to be -14. This is going to be -13, -12, -11, -10, -9, -8, -7, -6, -5, -4, -3, -2, -1. This is the negative indexing. This is what a string memory model. For every string, this is the internal memory allocation. String is collection of characters. String supports indexing. String is immutable. String cannot be modified. Adding characters, deleting characters, changing characters in the string is not allowed. Okay, this is string memory model. I hope all of you understand this. Once let us observe this practically. This is S1 is the string object. So these are the individual elements of the string. By following the positive index, each and every element I am accessing. Okay, now you run it and observe. Observe the IDs also. H, first letter, 0th indexed element. This is ID. E, one indexed element. Of course, here is one more E. Here is one more E. ID is the same. L, two indexed element. Here is one more L. Here is one more L. ID is the same. O. Here is one more O. Here is one more O, ID is the same. Blank space. Here is the one more blank space, ID is the same. So on. The same string object, same collection of elements I'm accessing using a reverse index. So it gives you in reverse order. Same object, same elements I'm accessing in the reverse order. So here we can understand about string object, collection of characters. String supports positive index and negative index. Its memory allocation practically we can observe, we can understand here. And one more point, string is immutable. We cannot change individual characters in the string. We cannot add or delete characters in the string. Just you observe, welcome is the string. What is the 3 indexed element? C is the 3 indexed element. Of course, I am trying to modify that. It does not allow. It gives an error. C is the 3 indexed element. I am trying to modify that. String object does not support item assignment because the string is immutable. Okay. So, you know, type function gives you what is the data type. ID function gives you what is the memory ID. Len function gives you what is the length of the string. Len function gives you what is length of the string. Next, let us understand string slicing. String slicing. Once you observe, of course, in other languages, the same activity is done using the substring function. Substring function. But here it is string slicing. The syntax of the string slicing is string is nothing but string object enclosed within square brackets. In the square brackets there will be 3 parts. One is the starting point. Second one is the ending point. Third one is a step. Here starting point is optional. By default, starting point is beginning of the string. If you are going in positive direction, beginning of the string is 0th index. If you are moving in reverse direction, beginning of the string is -1 index. Starting is optional. If you specify starting index, it works. It begins from whatever you specified. If you does not specify starting, by default it is beginning of the string. Ending is also optional. If you specify ending point, it will read up to the ending point. Up to the ending point, that means what? The ending whatever you specified, that is not included. Ending -1. If you specify 12, 12 indexed is not included. 11 is included. This is always ending -1 if you specify. If you does not specify the ending point, by default it will go up to end of the string. By default it will go up to end of the string if you does not specify. So ending point is also optional. Step is also optional. You can specify step 1, step 2, step 3 and so on. If you does not specify step, by default it is a step 1, either positive direction or negative direction. By default it is step 1. Okay. If you does not specify step, if you specify step is -1 or -2, it will move in a reverse direction. If you does not specify step, that is +1. Of course, you can specify positive step 1, step 2, step 3, step 4 and so on. You can specify. This is the syntax of the string slicing. Actually, already we discussed the string is immutable. So this string slicing returns a new string object. The string slicing returns a new string object. It returns a new string object. Original string, existing string object, the original string object doesn't get modified because string is immutable. The string slicing always returns a new string object. This is syntax of the string slicing. Just observe this. Go through this example. This is the string. Yes. Hello, welcome to Python programming. This is the string. Length is 35 characters. So positive index begins with 0, ending with 34. The reverse index, negative index, begins with -1, ending with -35. This is string object. So 6:12 starting point is specified, that is 6 index. Ending point is specified, that is 12 index. So that it is 12 minus 1. 11 is included, 12 is not included. Step is not specified. So by default, step is 1. Step is not specified. So by default, step is 1. Okay. So what will be the output? 6 index, 7 index, 8 index, 9 index, 10 index, 11 index. WELCOM. This is the output. Okay. Similarly, you see 1:5. Starting is 1, ending with 5. 5 means 5 minus 1, 4. By default, step is 1. So 1 index, 2 index, 3 index, 4 index. ELLO. This is the output. Just observe here, starting is 0. Exclusively I am specifying starting point is 0, ending point is 4. Step is not specified. So by default, step is 1. So 0, 1, 2, 3. 4 is not included. 4 minus 1, 3 is included. So HELL is the output. So here starting point is not specified, ending point is given 4, step is not specified. So step is not specified, so step is 1. Since it is positive 1, it is positive directional reading. So beginning of the string is 0th index. So 0:4. That's all. This and this both are same. So 4: starting point is specified 4 index. Ending point is not specified. Step is also not specified. Step is not specified, so it is positive 1, so it is positive directional reading. So begin from 4 index, 0, 1, 2, 3, 4 up to end of the string. This is the output. So here I gave 1:9. Starting is 1, ending is 9. 9 means 9 minus 1, 8. Step is positive 1. So 1 index, step 1, 2 index, step 1, 3, step 1, 4, step 1, 5, step 1, 6, step 1, 7, step 1, 8. ELLO space WEL. This is the output. Exclusively you are specifying step 1. Either by default step 1, exclusively you are giving step 1, positive 1, it is the same. So here I give step 2. What does it mean? 1 to 8, 1 to 9, 1, 2, 3, 4, 5, 6, 7, 8. This is the range. This is the range. Starting is 1, ending is 9. But it is not step 1. It is a step 2. It will read the 1 indexed element. It will take 1 indexed element E. And step 2, 1 plus 2, 3. 3 indexed element L. Plus 2, 3 plus 2, 5. 5 indexed element, that is blank space. Plus 2, 7 indexed element E. Plus 2, that goes to 9, that is out of scope, out of range. So EL space E, this is going to be the output when you give step 2, right? Understand? Yeah. Okay, next you see 0. Starting point is beginning of the string, that is 0. Ending point is 14 because step is 3, positive 3. So positive directional reading. So starting is 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is the range. 0:14. This is the range. Is it taking all the characters? No, it is not step 1. It is a step 3. Step 3 takes. So 0th indexed element H. Step 3 plus 3. 3 index 0 plus 3. 3 indexed element L. Plus 3, 6 indexed element W, plus 3, 9 indexed element C, plus 3, 12 indexed element E, plus 3, that goes out of range, more than 14. So H, L, W, C, E, this is the output of 0:14, 0 starting, 14 ending, step 3. Okay? Understand? So here just I gave like this: starting point is not specified, ending point is not specified, step is not specified. So step is positive 1, so it is positive directional reading. So beginning of the string is 0, end of the string is last character, it gives you total string. So this also the same: starting is not specified, ending is not specified, step is exclusively specified, positive 1. This also gives you total string beginning to ending. Here step I specified -1. Whenever I gave step -1, it is a reverse directional reading. Whenever I give -1, it is a reverse directional reading. Okay, so it gives you reverse of the string, -1 to -35, beginning to ending, reverse of the given string. Okay, just you observe this example: -5 to -13, -5, -6, -7, -8, -9, -10, -11, -12. -13 is not included. So MARGORP space, because it is -1, reverse directional reading. The index, starting index, negative index, whatever I specified is compatible for the reverse directional reading. So this is the output. If at all I give -13 to -5, then this is the range. It is not the indexes, starting point, ending point, whatever I specified, that is not compatible to the reverse directional reading. Since I gave -1, it is reverse directional reading. So it gives empty string, nothing. Because -13 to -5 is compatible for the positive directional reading, it is not compatible for the reverse directional reading. That's why it gives empty string. Here you see -5 to -13. This is compatible for the reverse directional reading. But what I gave step 1. Step 1 in the sense positive directional reading. The indexes, starting point, ending point, whatever we specified, that is not compatible for the positive directional reading. So it gives empty string. So -13 to -5 compatible for positive directional reading, so it is reading positive directional. 14 to 4, that is compatible for the reverse directional reading, so it is reading in reverse direction, right? This is about string slicing. Please remember, today the string memory model, whatever I explained, that is applicable for the data structures list object, tuple object. List memory model, tuple memory model is the same as a string memory model. List, tuple, any collection, array, numpy, we use slicing mechanism. The string slicing, whatever I discussed today, that is same as it is applicable for list, tuple, array, any kind of collection object wherever you do perform slicing. This is string slicing. List slicing is also the same, tuple slicing is also the same, array slicing is also the same, numpy array slicing is also the same, right? Yeah, please remember this. This is about string slicing. All of you comfortable about string memory model and string slicing? If any questions, please go ahead. Please ask me. Feel free to ask any question, whether it is serious question or silly question. Question is always question until it is answered. All of you clear about this?
Yes.
Okay, fine. I hope everyone is good. Next, string operations. Already we understand plus operation in between two strings. Left operand is a string, right operand is a string. So plus symbol work like a concatenation operator. So first name, last name, these are the strings. Left operand string, right operand string. It works like concatenation. This multiplication also already we understand. This works as a repetition operator. Scalar multiplication works like a repetition operator. Len function already we understood, gives you length of the string. The membership operators, in operator, not in operator, already we understood. Okay, whether it is available in the collection or not. This also already we understood. Then comparison operators, string comparison. Just you observe, string 1 I gave India, string 2 also I gave India. So string 1, string 2 both are equal, so it is true. Equal to operator gives you true, not equal to, greater than, less than gives you false. Okay, here I am giving Srini is the string 1. Next also I am giving Srini but capital S. But here both are not equal because S is small s, capital S. So not equal is true. S1 is greater than S2, true. Why? Small s ASCII value is bigger than capital S ASCII value. So based on the ASCII values of these characters, S1 is bigger than S2. I think this is how we compare the strings. This is a string comparison. Next, we have string functions to work with string operations. Upper function convert into uppercase, lower function convert into lowercase, capitalize convert into capitalized case. First letter of the string is capital, remaining all are small. Title method returns the title case. See, observe carefully, these are not functions. These are methods of the string object. Okay, these are methods of the string object. And swap case, just to swap the cases of the character. Count function, count the number of occurrences, starts with check whether it is starting with so and so, ends with check whether it is ending with so and so, is alphanumeral, is alphabets only, is full of numerical digits, is uppercase, is it lowercase, is it title case, is it spaces, full of spaces, and L strip, R strip, these methods are there. These things we discuss tomorrow. So it takes very little time to complete. Tomorrow we'll complete this string operations and we'll go to the third chapter, that is control structures, program logics and techniques. So if statement, while loop, for loop, how to work with Python. So tomorrow we'll complete this strings chapter and go to the third chapter, control structures. Okay, so today we do stop here, and today I will send you, already I send you the first chapter to your mails. Only 4 people are send me your mail IDs. For those 4 mail IDs I sent the material. Today I will send you the second chapter also. Tomorrow we have class, right? Why everyone is silent? Tell me yes or no.
Yeah, yes, Srinu.
Yeah, Srini, yeah.
Tomorrow we have class. Tomorrow Saturday, but even we have class tomorrow. Okay,
Okay.
because we are working in
So
fast track.
tomorrow also same timing, right?
Same timing, no changes in the timing. If necessary, in the last week, one weekend, I will take full time. Okay, 8 hours. Okay, that I will let you know. At present, don't worry. If the thing is going smooth, that is not necessary. If necessary, the last week, okay, I will take more than 6 hours in a day. Okay, if necessary. Don't worry about it. Go in your smooth way. We will discuss it at the ending if it is necessary. So Saturday is also working day for us, but Sunday is holiday. Timings are same, no change in the timings. Okay. Okay, all of you fine. Today we